The chain rule gives us a very specific result when we apply it to e to the u, where u is some function. I'm just abbreviating u here, so u can be anything. In fact, here's two examples. F of x equals e to the sine x, for instance. Alright, so we can have e to a trigonometric function and still take the derivative. We might have g of t for part b, e to the power of the quantity tan squared t plus t squared. Right? We can really go to town with this once we establish a very solid rule for e to the u. And it just follows from the chain rule, so you don't even need a separate rule for e. I just want to be clear on what that rule might be, or what we need to do every time we see e to the something when we're dealing with the chain rule. So here's the chain rule. It says that the derivative of f of u, the whole thing, where u is some other function in here, right? That can be anything, some crazy function, polynomial, trig, but it just says you take the outside derivative times the derivative of the inside. Now with our function e to the something, right, f of x, I don't even know what it will be. Well, let's just call it e to the u, right? The outside function is e to the x, e to the u. So f prime of x is the derivative of the outside times the derivative of the inside. But the derivative of the outside, the derivative of e to the something, is always e to the something. So e to the u, again, we just copy and paste the function times the derivative of the inside. So just to make it look real nice, we have e to the u quantity prime is e to the u times u prime. Now you can go through all the reasoning to apply the chain rule every time you see an e function, that's fine. But I kind of like this shortcut where we just know that e to the u prime is e to the u, you just rewrite the function times the derivative of whatever's in that exponent of e. So let's try it out on part A. We have f of x equals e to the sine x. So then the derivative, f prime of x, is, okay, well, we first just take the derivative of the outer, which is e to the something. The derivative of e to the something is just e to the something, right? So you always just copy this original function for the first part of the derivative every single time with an e function. Now times the derivative of the inside, well, the inside of this is sine x, derivative of sine x is cos x. There we go. Once you get the swing of this, these e derivatives can go really quickly. Let's look at b. We have g of t equals e to the tan squared t plus t squared. Okay, so a lot going on in that exponent. No worries, we apply the same principle. G prime of t equals, all right, first we just rewrite the function, e to the tan squared t plus t squared times, and now we take the derivative of the inside. Well, here for tan squared, we need the derivative of the outside, so we have the chain rule going on inside here. So the derivative of tan squared will apply the chain rule to that, 2 tan t times, now we need the derivative of tan because we need to take the derivative of inside until there's nothing left. So the derivative of tangent is secant squared t plus, and now we're on to the t squared term. Derivative of t squared is 2t. And there we have the derivative. So keep that quick little shortcut in mind as you proceed through the exercises and even beyond this section. You'll see e to the something a lot, and we'll need to take the derivative of it. It should be a quick derivative, especially if you know this principle.